Hello everyone, my name is Simon, and for this natural language processing final project, I will study London's opportunity areas policy through the lens of the urban planning text. And so my main goal is to understand not only whether opportunity areas are associated with better outcomes overall, but also why the outcomes differ so much across the different individual opportunity areas. And so I test whether the content and emphasis in the planning documents can actually help in explaining this heterogeneity. So the opportunity areas in London are the major growth areas designated in London-wide planning and starting from the London Plan back into 2004. So the policy intention is really straightforward, which is to concentrate the development in the selected areas to deliver housing, jobs, infrastructure, and often the public transport improvements. And so in this project, I treat the opportunity area as a city-scale planning intervention, and I evaluate whether the policy's stated goals actually appear in the measurable outcomes. So for the research objectives, I focuses on four outcome dimensions and that can map directly onto the policy goals. The first one is the public transport accessibility, which is actually measured by a matrix called PTAL, which is actually developed by the Transport for London. And the second one is the housing affordability using the price to income ratio, and the price is actually the housing price paid, and all collected from the UK National Office of Statistics. And for the infrastructure, this is actually proxied using the OpenStreetMap-based infrastructure and the points of interest. And also, I have undergone some spatial analysis to process the data. And the final one is actually the building height, and which actually represents the development intensities using the building height data from the UK Ordnance Survey DGMaps. So my research objectives are first, to test the average policy effects using a baseline quantitative model regressions, and the second is to actually further investigate the heterogeneity across the 47 opportunity areas and test whether the planning documents can actually help explain that variation. So before starting doing the natural language processings, I built a baseline econometric analysis using a two-way fixed effects panel regressions. So a key design choice is that I do not really use a simple opportunity area dummy variable, and rather I just compute the opportunity area exposure intensities as the percentage of each MSOA's land area covered by the opportunity area. So, sorry. So the MSOA is actually a kind of the geographic analysis unit in the UK. So in the United States, it's going to be like the census tracts, something similar. And I also align the timings by setting the opportunity area coverage to 0 before the opportunity area designation year. And I include the MSOA fixed effects and the year fixed effect. So that's a two-way fixed effect. And so the overall, the baseline results suggest that the opportunity area exposure is statistically significant and related to the outcomes like the public transport accessibility, affordability, and the building height. But infrastructure does not have any significant output results. So this map visualizes the baseline findings more intuitively. So my main takeaway is that the red squares actually represents the spatial locations, designations of the opportunity areas in London. So even if the average relationship is significant, but that does not necessarily mean that every opportunity area is going to perform in the same way. So in fact, the data actually suggests some strong spatial variations, and this really motivates my next research step to actually explicitly modeling the opportunity area level heterogeneity using the natural language processings. So I decomposed the total opportunity area exposure into 47 separate opportunity area specific exposure variables, and one for each of the opportunity area. So this lets me estimate the opportunity area specific coefficients for the public transport accessibility, affordability, and the height, and while still respecting each of the opportunity areas starting year. So the results show large differences across the different opportunity areas in London. So some have very strong positive associations, while the others are quite weak, and some of them are even negative. So this really motivates my natural language processing question, which is that this variation reflected in the local urban planning context. and the different planning documents. So to make the opportunity area level effects comparable across the different outcomes. So I actually standardize all the coefficients for each opportunity area using the Z scores. So this will just provide an interpretable ranking of which OAs actually appear to perform better or worse or have different magnitudes of the effects on different parameters like the public transport accessibilities or the affordability. And so for the natural language processing data and methodology, I use the planning documents linked to each of the opportunity areas. So the London May has specified that each of the opportunity areas in London actually have a specific planning document attached to that. So this can have different forms like the opportunity area planning frameworks, or it can be the area action plans, or it can be the supplementary planning documents. So methodologically, I used 3 layers. The first one is the LDA to extract the topics and update the topic proportions per opportunity area. And then I can regress the outcomes on the topic shares. And then I used a structured topic modeling for a more structured topic model that can actually incorporate the metadata and improve the topic selection and interpretations. And finally, I'm going to also use a keras, like a simple neural networks, and for the prediction models to test whether the text features can directly predict on the opportunity area outcomes. And first, I can start with some simple embeddings, and then I'll try out some of the more advanced settings like the SBUT, which is the sentence transformers embeddings. So for LDA, my first step is to document the processing. So planning texts are very long, so I convert the PDFs to text. I'm using a library in Python, which you can actually call the PDF Plumber. And then after acquiring the texts from all the planning documents for each opportunity areas, I can then split them into the paragraph level documents to improve the topic stability. And then I clean the text a little bit, as you can see from the coding step. And using the standard natural language processing steps, I convert all of them to lower cases and remove many of the popular English stop words. And then I conducted the lemmatization using spacing. And therefore, I only keep the alphabetic tokens. And so this can give me a very consistent corpus, which will be very suitable for the topic modelings. And then I train the LDA models using the Gensim library. So I built a dictionary and a bag of words corpus, and then I test the multiple values of K from 2 to 20. And this is very clear in my code. You can see there, and also you can check out my codes from the notebook. And for each of the K, which is the number of the topics, I compute the topic coherence and the topic exclusivity scores to avoid choosing K based on not from like an evidence-based approach. So the goal is actually to select a topic solution that is both meaningful and interpretable from the policy context. So here, from the diagram, you can see that I normalize the coherence and the exclusivity and combine them into a composite score to guide my K number of topic selections. So my final choice for the LDA is actually K equals to 6, because it sort of balances the interpretabilities and the topic separations without producing like overly fragmented topics. And especially you can see there's a very sharp increase and after 15, but when I actually observe but you're going to see from my notebooks as well, if you observe them, you will see that each of the topics is actually very relevant to only one opportunity area. And therefore, and some of the more general and more crucial topics like the economics and like the transport, like urban planning may just be overlooked. And if we just increase our number of topics to a very high value, so this slide summarizes how I interpret the 6 topics using their top words. So broadly speaking, the topics correspond to themes like environmental sustainabilities, and all of these actually based on the top words I actually printed out, and you can check out some more details from my notebooks. But the themes can actually include environmental sustainability, climate-related planning, transport, accessibility, spatial planning and urban design frameworks, and finally the economic development. So after the interpretations, I think the key output is actually the topic proportions vectors. So for each of the opportunity area, I estimated how each of the topic actually appears in its documents for each of the opportunity area, and this is actually because the LDA is a probabilistic model. And so the next I regress the opportunity area outcomes on the topic proportions. So to avoid the perfect multicollinearities, I dropped one topic as a reference category, and the results actually suggest that some topics, especially those that look more like sustainability and governance framing, are very significantly associated with outcomes like the affordabilities and the public transport accessibilities. And while the topic-based explanation for building height is much, much weaker. So after the LDA analysis, I want to move to the structured topic modelings using R. So the pre-processing is very similar, but I uses the structured topic modeling workflow to produce the documents and vocabularies in the correct format. So the structured topic modeling is very useful here because I think it supports more systematic model selections and the easier integrations of the metadata for interpretations for different opportunity areas. So here I organize my metadata, as you can see that, and including standardized outcomes of the control variables like the area. So these are actually generated using my codes from my last slide. I also include a classification variable representing the stage and the status of the opportunity areas, and that is because, like, say, a maturing and an underway opportunity area are expected to have very different local impacts. And so for these two diagrams, I use search K to actually compare the coherence and exclusivity across the different topic numbers. So my final, as you can see, that my final topic number of the topics K here is actually 7 because it produces very stable and interpretable topics and avoids some excessive fragmentations. And here, and as you can see though, here from 6 of the topics, and then I also printed out the top words, the top most popular words, and also the related word clouds. And you will notice that there are only 6 word clouds here because one of them is not really recognizable and full of very funny tokens. You can check that out from my notebooks. But compared to LDA, the structured topic modeling looked much more aligned with the planning language. So for example, the themes about the redevelopment processes, the town centers, open spaces, and transport stations, and these are much more related and according to our expertise fields, because my background is actually urban planning. And then I use the estimate effect. So for each of the topic, I sort of like it now. I have an idea about like what this topic is really about based on the word clouds. And you can also check it out my own categorizations for different topics from my notebooks. But then I use the estimated effect to test how the topic prevalence actually changes with the outcomes. So intuitively, I interpret each topic as a planning emphasis direction, and then I test whether stronger emphasis on certain things is associated with higher public transport accessibility or affordability or the building intensity, which is the building height. And from the table, you can see that the status of the opportunity area really matters a lot. So for example, the higher effects of Z score for building heights are really related to the infrastructure development topic prevalence, and these can be valuable for future urban planning, policy making, and document drafting. And this table is also available from my notebooks, and my interpretations in the report is much more detailed, and so this carry some very valuable insights for the future urban planning and policy making. And so finally, I tested whether the urban planning document text can actually help predict the outcomes directly and to help predict the effect on the different parameters. The first, I built a baseline model using tokenization, so padding into a fixed lens, as you can see from my code, and a simple embedding layer with a small neural network, which is a very simple one. You can see from the architecture stuff to predict the 3 outcomes, and which are the Z scores for the public transport accessibility level, affordability, and the height, the building height. So firstly, I built a baseline model using the tokenization and padding to a fixed lens and a simple embedding layer with a small neural network to predict all of them. The training curves, as you can see from the 2 diagrams below, suggest that the model learns more signals, but the generalization is actually not that grade, as you can see in the orange line. So this actually motivates me for stronger representation. So thinking about how to improve my model, and I want to replace the simple embedding layer with a much more advanced, which is the SBERT, the sentence embeddings, and then I train a small multi-output regression model on top of these embeddings. So the performance, as you can see, especially for the two diagrams and below, you can see that the performance actually improves a lot in terms of the loss functions and the mean absolute errors. The key takeaway here is that it's not that the prediction is actually much more perfect, but the text really contains some meaningful predictive information about the opportunity area outcomes on the different parameters like the transport accessibilities or the housing affordabilities. So this really supports my idea that the planning documents may help explain heterogeneities of the performances of some of the urban regeneration policies on different areas. So you can check more details from my report. And so far, these are my presentations. And thank you very much for listening.